Hi everyone, Mrs. Kruger here. Today we are going to talk about phase changes. So what are phase changes? Well, it's change from one state of matter to the next. In last week's video, we learned about the particle arrangement of solids, liquids, and gases. We know that the atoms of a solid exist in orderly patterns like this one. This is a representation of ice. Each one of these molecules is a water molecule. The red represents oxygen, and the white represents hydrogen. Remember that the molecules or atoms of solids contain the least amount of kinetic energy. The water molecules in ice will vibrate in place, but they aren't moving all around. Here, I've arranged my water molecules into nice neat patterns to represent ice inside of this container. This would be as if I just removed this container from the freezer. All of the water molecules are organized and vibrating in place. I'm now going to add heat energy to these water molecules. I'm representing this by drawing some flames at the bottom of the container. What do you think is going to happen as these water molecules gain more heat energy? That's right, the ice is going to melt. Eventually, these water molecules will gain enough heat energy to break their nice neat patterns, and they'll start moving all around. I want you to imagine that these water molecules are like people at a party, but a party with no air conditioning. As the music starts playing, people start moving and dancing all around, and the room keeps getting hotter and hotter. Just like the music at the party energizes the people, the heat energy is allowing the water molecules to gain more kinetic energy, break their bonds, and start flowing over one another. Eventually, the solid ice turns to liquid water. Remember that liquid water molecules are more loosely arranged than molecules of solid ice, and they can flow over one another. That's why we call liquid water molecules fluid. The molecules of a fluid can be easily poured from one container to the next. So now things at the party are really heating up. People have been dancing and moving all around, and remember, there's no air conditioning. People decide they're going to start spreading out a little bit. In fact, some people decide they're going to leave the party altogether. As we continue to add heat energy to the container, the water molecules gain enough kinetic energy to break the bonds of the liquid and start spreading out in the container. The water molecules are turning into vapor, which is a gas. The water molecules can even leave the container and start spreading around the room. They have enough kinetic energy to fill any container that they are in. Remember that the molecules of a gas have the greatest amount of kinetic energy. They're really disorganized and spread very far apart. When matter changes from solid form to liquid form, we are always adding heat energy. We increase the temperature, and the solid absorbs the heat. It's important to remember that heat energy always moves from hot to cold. As we take the ice cube out of the freezer, it's absorbing heat energy from its surroundings, changing from a solid to a liquid. We call this an endothermic reaction. The prefix endo means within, or from inside. So the heat is moving into the ice cube. The ice cube's absorbing the heat. And thermic always has to do with temperature. We call this transition from solid to a liquid by adding heat energy melting. What if I take my liquid water and put it in an ice cube tray and pop it back in the freezer? Well, then the liquid water is releasing heat energy to its surroundings. Remember that heat always moves from hot to cold. So as the liquid water is releasing heat energy, the molecules form those nice neat patterns again and form into solid ice. We call this an exothermic reaction. Exo has to do with being outside of, so the heat moves outside of the liquid water. And again, thermic always has to do with temperature. We call this transition from liquid to solid by removing heat energy, freezing. What about a change from a liquid to a gas? Do you think we have to add heat energy or remove heat energy? We definitely have to add heat energy to the liquid. Think of a puddle sitting outside in the sun. The liquid water absorbs heat energy from the sun. the molecules gain enough kinetic energy to break their liquid bonds, and they vaporize. So the liquid water becomes water vapor, and the gas molecules start floating around into the air and move up into the atmosphere. This is going to be an endothermic reaction because the liquid water is absorbing heat energy from the sun. We call this process, the transition from a liquid to a gas with the addition of heat energy, vaporization. What if we're transitioning from a gas back to a liquid? Would we have to add heat energy to the gas or remove heat energy? We would have to remove heat energy from the gas. This might happen during the night when the temperatures start to reduce, the water vapor in the air will cool down, the molecules will lose heat energy to their surroundings, and then they'll start collecting again, for example, like the dew on a leaf. We call this an exothermic reaction because the water vapor is losing heat energy to its surroundings. We call this transition from a gas back to a liquid condensation. Thanks for watching, everyone. Have a great day.